Hi, my name is Matthew Diesner, Regional Manager for the Wireless Telecom Group, the Test and Measurement Division, Booten and Noisecom. Today, we're going to discuss the use of using peak power sensors, broadband sensors, and measuring power out of an amplifier and compression techniques. There are advantages to using peak power over average power. Today, I'm going to be using a demo aid that is a 14 dB amplifier that is at 2.5 gigahertz center frequency, and we're injecting noise onto the signal of this pulse. What we're going to demonstrate then is how we can look at gain and compression. If you look at the screen, what I'm showing here today is the yellow is the input to my amplifier, the blue is my output of the amplifier, and I have two cursors. Using average power sensors only, we see these highlighted yellow lines and blue line. That's going to show us the average power between our markers. But what's going on, since we have a noise being injected onto this signal, is that we're actually looking at OFDM modulation that is being used in LTE and Wi-Fi communication devices. So what happens as we're looking at gain in an amplifier, we're going to actually see compression techniques that are taking place. If we switch to CCDF, complementary cumulative distribution function, and what we have in statistical mode, we can look at our average power, and see we have our gain here, but we also are looking at peak power at various points in time. Yellow being the input to my amplifier, blue being the output of my amplifier, and then we have different cursor here. This is my average power percentage of time, and then this is my peak power in reference to my average. So as I start increasing the amplitude into the amplifier, I will start seeing a compression that is taking place. And as we're going to see in these lower percentages, the separation is occurring. And what we're looking at here in our chart is that our average power basically stays about a 14 dB gain, but what we're noticing is at various points, especially here, we're starting to see a 1 dB separation already at 0.01%. This is affirming that we're seeing compression take place of these peak to average signals. Crest factor is a very important measurement. What makes our sensor unique from the other sensors on the market is we have video bandwidth to 195 megahertz. Other sensors stop at about 30 megahertz. And our real-time power processing also allows us to capture events as they're occurring up to 100,000 times per second. We do have some application notes on the website explaining this in greater detail. Our power reference guide also explains CCDF function in greater detail. Please visit our Booten website at booten.com, and I look forward to seeing you on the next video.